Well, welcome back to the arcade, and this is going to be part 2 of the Astrocade game console system. And we found out in the first video we got it working, but we found out we have an overheating problem. Now, it's a well-known fact in the Astrocade game circle. There are a lot of collectors out there that have these games, and they love these games, and still kind of going strong. But there's also a lot of people have been saying that, they have heat-related issues. They'll overheat. So in the last video, we did find out that we have an overheating problem with this one. Now, this one, I haven't done anything to it as of yet. I did order a cap kit for it. So I just individually ordered a set of caps for it. I got these from Arcade Parts and Repair. And so we're going to install a cap kit in it. Also, off of eBay, I ordered some voltage regulators, 10-volt voltage regulators. These are the LM 342-10. So I got a new 10-volt regulator because we discovered that the 10-volt regulator is what was overheating, and when it overheated, it would lose its voltage, and the voltage would fall right out and just drop right off to nothing. And with the factory heatsink, all right, this is the factory heatsink right here. And I have it on a new voltage regulator just to show what it looks like. Okay, with that factory heatsink, it was getting temperatures up to 135 degrees. And that's when it started to flake out. This provides the voltage for the 3 custom chips, which a lot of people think that the custom chips overheating is the problem, but it very well could be in some units. But in this particular unit, and at least one other that I've seen had the same exact symptoms on a video on YouTube, I believe that that 10-volt voltage regulator overheating is what causes the whole problem. Okay, and that's the main source of the overheating issue in the Astrocade game console. Now, I'm not saying that's the only reason because, like I say, you also have your 5-volt regulator, you have your -5 regulator, and you have a 15-volt regulator. If any of those go bad, or if you have any of the capacitors start to short out, or any other components go bad, you can have other issues. But I'm saying with a game system that's working and just appears to overheat and you start to see streaks on the screen, I'm willing to bet that it's that 10-volt regulator overheating going bad. Now, is this a design flaw issue, or is it just a case of old age and the regulator going bad? I don't know. But we're going to try to find out in this video. So what I'm going to do is I've set this back up. I've set it up with my small screen because all we need is just to be able to see what it's doing on the video screen. I set up my voltage regulator, and I have it on pin 40 of the custom address chip right here. This is the custom data chip, this is the custom address chip, and this is the custom I/O chip. All 3 of these chips run off of this 10-volt regulator supply, but there are different pins that they run off of, like the this chip right here, the address chip is pin 40. It's the 10-volt pin. The custom data chip, the one with the heatsink here, I believe it's pin 13 is the 10-volt line. And I'm not sure about the I/O chip. We can look on the schematics and find it, but I'm just interested in what this 10-volt regulator is going to do. Now, what I did was I pulled the factory heatsink off of it, and I ordered on eBay a bag of heat sinks. Now these are 220 for 220 style cases, but they will work on the voltage regulator that's on the board here. So what I plan on doing, and I've already done, is I put two of these together to form one big heat sink, and I've actually put it on the original 10-volt regulator that's on the board. I haven't done anything to the board except put this heat sink on the board here. And there it is right there. It actually fits in there. It doesn't hit anything. It clears everything. You put the keypad down on it, it clears. So this is the original heat sink. And I put two of these together to replace the original heat sink. This will give us a much more broader heat dissipation than what that original one does. So what we plan on doing first, I got the voltmeter hooked up to it, got it all set up ready to go, got my thermometer here, infrared thermometer, and it's kind of cool in here. The weather storm went by and it cooled up, and right now it is 61 degrees in here, so it's a lot cooler than it was when I made the first video. So that could play a little bit of a part in it too, but we're going to start off with everything. It's about 61, 62 degrees on the whole board because I haven't fired it up yet. So let's go ahead and power it up and make some heat. Turn the VCR back on. And we're up and running. Now, we have 8.44 volts right now on the 10-volt regulated line. Now, my question is, why do we only have 8.4849, almost 8.5 volts? There we go. It's gone up to 8.50, so that's 8.5 volts. And it's actually climbing a little bit. All right, well, we'll leave this on and we'll monitor it a little bit and see where it goes. And we're going to see how hot that gets. Now, with the original heat sink on it, it was getting, like I say, about 130, 135 degrees. So we're going to check it once it warms up and see what we're getting with that larger heat sink on it. Now, I did a lot of research on this, trying to figure out if anybody else had this problem and if anybody had solved the problem. A lot of people have the overheating problem, but not a whole lot of people have solved it. One person said they solved it, and I'll show you what they did. There was actually a write-up in it in the Arcadian, which was a newsletter from back in the day. This particular one here is Volume 3, Number 7, May 8th, 1981. This was a newsletter that Astrocade users subscribed to back in the day, and it was mailed to them in the mail. This was back before the internet and all that good stuff. And it had all the latest updates about the Astrocade system, new games coming out. It also had homebrew games that you could type in using the Bally Basic, and it just had a lot of general information about the system. And I got this from a website called Bally Alley. So if you go and do a search for Bally Alley or go to www.ballyalley.com, you'll come to this website. And the guy who has this website has all of the Arcadians that were sent out. He has them all scanned in, and you can go and read them, download them, print them out if you want to, or whatever. So I real quickly went through them and just scanned over them. I didn't go over them with a fine-tooth comb, but I was trying to find anything about heat-related issues. And I did find some stuff. So here is, in the one issue, like I say, this was the Arcadium Volume 3, Number 7, May 8th, 1981, under motherboard modifications. Okay, and I'll read this. The following changes are recommended if your machine is having any of the listed symptoms. The author, Bally Astrocade, has sent us some inside information and can provide a small built-up edition ready for installation. Check his add-on, page 80. If your unit has these symptoms: screen tearing, loss of horizontal sync on warm-up, unit goes dead, or keeps resetting after warm-up, then the following modifications will correct them. If your unit, went completely dead following these symptoms, these modifications will probably repair it. Necessary modifications: replace the 74 LS74 at U16, the clock, with a 74 S74. Replace driver 75361 U32, an 8-pin clock again, with Klug board assembly. That must be the board he was talking about you can get from him. If anybody doesn't know what a Klug board is, it's usually a crude board that somebody puts together, sort of like a home brew on a breadboard or whatever, to modify a circuit in a computer system or a gaming system that's supposed to fix a problem. Basically, that's what it is. Note, be sure to heat pins enough to cause solder to flow around double-sided foils, as there is no way to see if there is a good connection once the board is in place. Remove crystal, extend leads, cover with spaghetti or heat shrink tubing, place substitute insulating material over board to prevent crystal from shorting points on top of the board. Lay crystal flat back over top of Klug board. Caution: use extreme care when removing the 75361 driver. If plated through holes are pulled out during removal, repair by pushing thin wire through bottom of board, bend over, and solder to top foil. Then install and solder Klug assembly. Cut off excess wire on bottom. Number 3, remove resistor and capacitor, see diagram, and place jumper where capacitor was. These units may not exist on your board, or this may have been done by the factory. Okay, now here's my board right here, and this is what they're talking about right here. There's a capacitor. You replace the capacitor with a jumper wire. Okay. Well, here it is right here. This was evidently a factory mod, and there is a wire jumper right there. So that's already been done to this unit. So probably if you have an early unit, that's one modification that you can make. Okay. Then, let's see. Number 4, jump a 27 ohm resistor, R1, in the 10 volt supply, 1 watt, with a 47 ohm resistor, quarter watt or larger. There's that 10 volt supply again. So it says to jump a 27 jump a 27 ohm resistor R1. That's what's in the unit from the factory, a 27 ohm resistor at R1. And it says jump it with a 47 ohm resistor. Okay, here that is right here. As you can see, you got the large resistor and you got a smaller resistor just piggybacked on top of it. Obviously, that's another factory mod, and that is a mod to the 10-volt supply, which supplies the 3 custom chips, which happens to be the regulator that is overheating. Is there a connection? All right. That's the question. Okay, here is the schematic of the power supply on the Astrocade. You have your AC coming in from the wall transformer. This is the on-off switch. All these diodes here are rectifier diodes that rectify the AC. It has 2 AC transformers in the wall unit. So it has 2 sets of AC coming in to the power supply. And right here is the 10-volt output. So this is VR2. So this is the 10-volt regulator that I'm going to replace. And here is R1. This is the resistor that they tell you to jump that other resistor over top of, which was a factory modification. So this is the input of the regulator. This is the output of the regulator. This is the ground. So right here, the input goes through R1. And of course, you got this 1500 microfarad electrolytic capacitor, which is the only electrolytic capacitor in the 10-volt circuit. So the AC comes in through CR1, gets rectified, and down on this, let's see, down here, it comes in on CR7 and gets rectified. So it looks like CR1 and CR7 are the 2 diodes that are being rectified to supply the voltage to the 10-volt voltage regulator. So the input voltage, we don't know what that is, but it has to be greater than 10 volts. And of course that's unregulated because, well, the only thing that's past the diodes from it being rectified is the 1500 microfarad capacitor here. So, yeah. So what are they doing by increasing the resistance of R1 here? They're cutting the input voltage down to their voltage regulator. So will that cut the output voltage to the voltage regulator? You know, if it's a fixed voltage regulator, which I believe this is, I wouldn't see how that would affect it. Or would it just cut the amperage down? I don't know, okay? All I know is we're only getting, on power up, 8.5 volts from the 10-volt supply. Whether something on the board is dragging it down, that's something that we're going to have to look into, okay? So I just thought that was interesting. That they are, you know, specifying a problem with the 10-volt line and supposedly adding that resistor is a factory modification. Okay. Also, number 5, if you have a gray colored data chip under the keyboard, this old style unit, which can cause further problems with the clock and or memory, should be replaced with the new version, the black color, and properly heat sunk after cutting a hole in the top of the shield. Now on the earlier models, the heat shield also covered the front section. So this is a later unit that the heat shield only covered the back section. So you don't have to worry about that. But evidently, there was an older version of the custom data chip, and those gray chips, they called them. This is a black one, black plastic case. I've never seen a gray one, but evidently they must exist because it's here in black and white. So if you have an old unit with that gray chip, good luck. It's probably bad. Let's see, what else can we do here? You replace that, cutting a hole in the top shield. 6, it says replace the 82 ohm resistors in the clock, R12 and R13 with 47 ohm resistors. Okay, that's going back to that Klug modification again, which we don't have and we're not going to worry about. I just thought it was interesting that somebody had, mentioned that it was a problem. Other modifications, but not absolutely necessary. Put a jumper wire from the cathode of CR3 to the plus end of C6. Okay, that's another factory modification, because that's what this wire right here that's soldered to one of the rectifier diodes runs around the board and comes over here and runs to the 10,000 microfarad 10 volt capacitor. Okay, so that's another factory modification. If C19 IO is glass, orange and black replace. Check front edge of the keypad and file off any protruding leads. If the line filter in a metal box, the 1 by 2 inch, is high resistance type, no tape or not triode, replace with new style, low resistance. Put hot melt wax on base of keypad. Replace CR3 to CR6 with shoddy 1N5817 or equivalent. So that's all of the rectifier diodes. The wiring schematic for the Klug board. So they actually give you a schematic of the Klug board, so I guess you could recreate it if you wanted to try to replace that, what they call the Klug board that's in that clock circuit, which is underneath this shield right here. That's where that modification goes, underneath that shield. So, and it's interesting that that is powered by the 10 volt line. So maybe that also has something to do with the 10 volt line. Let's see. And that's all of that. Now, there was one other thing that I found in another issue of the Arcadian, Volume 3, Number 8, June 8th, 1981. It says, one of the modifications that have been incorporated into the Astrovision arcade motherboard is the reduction in the power supply voltage. Dan Copen is doing roughly the same thing to his Bally board. Crazy Copen's heatsink. Does your machine poop out after an hour of intense game playing? Do football players get mysteriously tackled by strange dots on the screen? Or does your game just stop as you are shooting your last space invader out of the sky? Well, Crazy Copen just might have the cure for you. The cause of all your woes is the data chip, U18. This little babe gets so hot you can fry eggs on it. And what's worse, it sits right under the keyboard, which makes ventilation nearly impossible. After trying everything short of installing an attic fan, a friend of mine, who shall remain nameless, after all, why should I share the credit, claimed this chip could run on much less than the 10 volts supplied to it. With trembling fingers, I wired a 30 ohm, 1/4 watt resistor on pin 13, and son of a gun, whoosh bang Willie, if it didn't work. And here it is. This is the custom data chip. And it makes me cringe because he pulled the leg of the data chip out of the socket and soldered a 30 ohm 1/4 watt resistor onto it. And then I guess soldered it down to on the board, bypassing the socket. It says the above drawing shows exactly how I did it, with one word of caution. Don't overheat pin 13 when soldering on the resistor. You may damage the data chip and have to replace it. Good luck with that. Okay, I have had great luck with this fix and now can leave my machine on indefinitely. Hope you have the same results. Okay, so much for that. So it looks like all of our problems are boiling down to this 10 volt power supply in the Astrocade unit. And evidently the factory had already, by the time this unit was made, had already made some modifications to bring that voltage down. Okay, so maybe originally this was actually pumping out 10 volts to these custom chips, and that could have been overheating the custom chips. But with their little modification, whether it's because of that piggyback resistor right there, I don't know. Maybe that's all it took. Maybe that is what's cutting the voltage down. Maybe that's causing the voltage regulator problems. Maybe it's just old age and the voltage regulator is on its way out. So anyway, I thought I would tie in to our Gorf game, because this Bally system, as you know, the custom chips are used in Gorf. They're also used in the arcade version of Wizard of War, Robbie Roto, Extra Bases, Space Zap, I think, and there's probably a couple more, whatever. So what I did was I got the schematic out here. This is the Gorf CPU board, which the Gorf CPU board has the custom data chip and the custom address chip. And I know for a fact that we're monitoring the voltage on pin 40 of the custom address chip. So here is the custom address chip, and here is pin 40, and the schematics, look at here. It says plus 8.5 volts. Right there. There it is on the schematic. This chip is supposed to get 8.5 volts. So, why do they have a 10 volt regulator in this? Must have been a design flaw, and that could have been in the beginning before they made the modifications was causing the problem. Okay, all the talking is done. Let's go ahead and get something done here. I know you're tired of me talking, but I just thought that this was something that needed to be said to try to explain why the 10 volt power source, why I think it's the cause of the Astrocade's overheating. And it could be why the custom chips go bad in the arcade games like Gorf. Maybe we need to check our power supplies and actually check the voltage on the custom chips, like I'm checking it right here, and find out what that voltage really is, because I did another video on the Gorf boards talking about whether the custom chips needed heat sinks or not. Would a heat sink help prolong the life of the chip? And some people came back and said, well, it's not actually because the chips get hot. The reason is because they are powered with too much voltage, or the voltage is what kills the chips, not the heat. But if you have too much voltage, then you're going to have more heat. So they kind of go hand in hand. So anyway, I'll put up a link to that video when I was, that's why I bought this temperature gun right here, to try to figure out whether these custom chips were getting hot and how hot they got, and whether I thought a heat sink would benefit. Okay, well, let's go ahead and see what we got. Now, this unit has a screensaver, and it's gone into screensaver mode, so I hit the reset and bring it back up. I thought it was something else wrong with the unit before I discovered that, yeah, if you do nothing with it and just let it set idle, it has a screensaver that just makes the screen go blank. Okay. So it's been on the whole time I've been talking. I don't know exactly how long that is, but it's long enough. And look at here, we're still at 8.32 volts. Now it goes down a little bit. Now it's 8.25. It kind of goes down and up. It kind of fluctuates a little bit. All right, so let's see what the temperature is now. First, let me just feel it. It doesn't feel bad at all. Okay. All right. Well, let's see if we can get a temperature reading on it. All right. The most I'm getting on it now is 114 volts. Now, granted, it's cooler in here tonight than it was when I took my initial readings in the last video, but I don't think the coolness in here is enough to make the difference between. This thing was reading with the original heatsink 135 degrees, and right now the most I can get is 115. All right, let's look at the custom data chip and see what that's running. All right, the most I've got on that is 109. That's a little cooler than what it had been running. Let's look at the custom address chip. $101. Now let's look at the custom address chip. All right, 116.7, that's the hottest that's getting. So they seem to be running a little cooler, but the main thing is the voltage regulator is not overheating and freaking out. It's still 8.2425, well, now it's gone up 832. So it kind of goes up and down a little bit. So yeah, 8.32 right now. But it seems to be fairly stable, and it's, before 130 degrees, I couldn't lay my finger on it. It's hot, but I can lay my finger on it and keep it on it. Okay, so quite possibly all I have to do is leave this heatsink on it and we'll be fine. But what I'm going to do is I'm going to go ahead and pull it down. We're going to install the cap kit, and I'm going to install a new regulator, and then we'll come back, we'll fire it back up, and we'll see if we have any difference in the voltage, and see if we have any difference in the heat dissipation, and what the heat of the custom chips are, and the voltage, and all that good stuff. So let me get to work, and we'll do the cap kit. And it's only like, what is it? 1, 2, 3, 4, 5, 6, 7, 8 or 9 caps. It's not many, so it won't take long to do it. So let's get started. Okay, let's get started. First I'll unhook the power supply here. Then I'll unhook the RF unit. Let's get that out the way. I wish this wasn't on here. I hate moving this back and forth so many times because I'm afraid I'm going to break these wires off here. But all right, we need to get the metal shield off the bottom, and it's held on with a bunch of Phillips screws around the board here. So let's go ahead and remove those. And let's see, they have lock washers on them. So I'm just going to put all of them right up here. Like I say, it's a bunch of these. But it's what you got to do to get to it. One more here. Okay, I think that's all on this side. Now, got one right here. Missed the lock washer on that one. All right. Here we go. One over here by the voltage regulators. And let's see. Let me get this joystick unplugged. Don't need that. Okay, we got one right here. Some kind of little fuzzy wuzzy there. I don't know what that is. Okay, got that one. Boy, they sure wanted enough screws in this bottom shield. And this should be the last one here by the reset button. Yeah. These metal tabs might be kind of holding it back here. There we go. All right. It has like a cardboard insulator between the circuit board and the shield. Interesting. All right. Let's go ahead and see if we can start. And let's go ahead and take care of these electrolytic capacitors. We'll start with the big ones here. Let's start with the 1500 at 25 volts. I'm going to replace it with a 1500 at 50 volts, which is still actually a little smaller than the original, which is usually the case. All right, let's see what kind of problems we're going to have desoldering this board. And And I just noticed they're not marked. Nothing on this board is marked. The only thing, it's got Bally Midway Manufacturing Company on it, the numbers of the board, but as far as components, the capacitors are not marked plus or minus, so I'm going to have to make sure that I get them back in the right position. This one here, the positive on both of these are near the front of the board, so yeah. And that one came out. And you know, I'm going to do these one at a time. That came out just like that. So negative points back that way. And when I install caps, I like to put the caps in so that you can see the which way the polarity is, and you can actually read the caps. So this one didn't clear out. It just pulled out. Alright, I got it. All right, one down and what, 8 to go? Yep. All right, I need my little snippers. All right, got that one. Now let's do this other one here. Okay, that was the last capacitor. Now we got to put in the voltage regulator. Now, what I'm going to do is unscrew the old one here and use the screw over again because it's a new screw. I got the screw out of a 220 installation kit, mica installation kit. We're not going to need the mica. We're just going to put a little heat sink compound on it and sandwich the tab between the two heat sinks. Now, this voltage regulator has a flat side on it. The corner, see this corner is flat? That's how you tell the polarity of which pin is which. The center is ground, but you got an input and an output. So this came off the board with it in this direction, so that's the direction we need to put it back in. Okay. Put a little thermal grease on the tab here. Little dab, do ya? Of course, it already had some on here. And this time, since it's going to be permanent, I'm going to put the lock washer on it. The kit came with a lock washer, so just so because of the heating up and cooling down, you want that lock washer on there to try to keep it from loosening up, because the heat sink's not going to do you any good if it loosens up. So we'll just put that lock washer on there to try to help prevent it from loosening up. And the reason I'm putting it on now is because it's a lot easier to install it while it's out of the board. Just trying to get it all straight. Doesn't have to be, but it just looks better. All right. And there we go. We've got our voltage regulator mounted on the heatsink. This is the flat corner. So we'll stick it in. Now let's see. That should be far enough in. Don't want to put it down flush with the board, but I don't want it sticking up too high either. Alright, I'll take a look at that with my magnifying glass. Looks good. Clip the leads off. And there we have it. All installed. Now, when I was flipping this around a while ago, I could have swore something fell off of it. I thought maybe it was the reset button, but I don't see nothing missing. So I'm going to take a little break, cut the camera off, and search down here and make sure nothing fell off. And I'll go ahead off camera and put the shield back on the bottom and get it all ready. And when I come back, we'll be ready to fire this up and see if it works. Okay, one more thing while I'm at it. I checked the pins right here where the RF connector is, and I checked where the joysticks plug in, and I did find a cold solder joint on here, so I'm going to resolder all these Molex pins right here. I didn't really see any on the joystick connections. So I'm probably safe there. But I did see one on this RF connection here. So while you got the bottom off, you might as well check where all these any connectors or pins are and reflow them, just to be on the safe side. Even though, like right here, the 3-pin connector where the light pin hooks up, nothing ever plugs into that, because as far as I know, I don't think anybody ever came out with a light pin. I could be wrong, but you know, what the heck. This is, if you get a memory expansion, I think you plug that in here. So while I'm in here, I'm just going to go ahead and reflow the solder on it too. And it'll be done. I'm going to look over these joystick ports, but they're kind of delicate, and if they look good, I'm not going to touch them. So, okay, let me go ahead and do that, and I'll put the bottom back on. Okay, well, it's the next night. Last night when I got through with everything, I looked at my phone, and it was 3 a.m. So I decided to go ahead and turn it in and wait till tonight. And I got it all back together, and we're all set up. We're ready to fire it back up. I haven't turned it on yet. Let's go ahead and get a room temperature. And it is 65 degrees basically. And so the console is at room temperature. Like I say, it hasn't been fired up yet. 66. So that'll give us a baseline. So let's go ahead and fire it up. And hit the reset. And let's see what we got. Look at there. We got 10 volts going to the chip. So we do have the new 10 volt regulator is putting out 10 volts. So that could be a bad thing. Well, now we'll be able to monitor the custom chips at 10 volts. And we'll be able to see if the chips are getting hotter with 10 volts as opposed to 9. I wonder if I could let's see, replace that 10-volt regulator with, do they make an 8-volt regulator? Do they make a 7808? I have to look into that and just make it or a 9-volt. I think they got a 9-volt regulator, 7809. Well, first let's just wait and see what happens. We'll go ahead and just let it warm up. And in the meantime, I guess we could put some games up on there and let it play itself. Let's see. Let's go ahead and let it do checkmate in a number of games. Let's do 10 games. And number of players, let's enter 0 so it just plays itself. And we're still holding at 9.99 volts. And we are taking that measurement directly off of pin 40 of the address chip, the custom address chip. So, yeah. Well, the I/O chip so far is cool. That chip is fairly cool. So is the custom data chip. Cool as a cucumber. All right, the 10-volt regulator is just barely warm, lukewarm. Let me go ahead and take a measurement here. Like I say, we just turned it on, but all right, the 10-volt regulator, (102). Okay, that's the coolest I've had it run yet. Let's see about the custom data chip here. Well, so far that's only running at 87 degrees. Let's do the I/O chip. All right, so far that's 95 degrees. All right, let's go ahead and do the one that we got the voltage. We're checking the voltage on the custom data chip. I mean the custom address chip. Okay, so far 106. Okay, so I'm just going to let it run a while and let it continue to heat up. We're still holding 9.98 volts. The voltage regulator is running steady. It's doing its job. So obviously that old regulator was shot because it was a 10-volt regulator and it should have been holding it at, like it is, around 10 volts, at least close to it. And we were only holding it about, once it warmed up, 8.32 volts. So yeah. All right, well, we'll go ahead and let this run a while and heat up, and I'll be back, and we'll make another check. Okay, well, it's been running now for a little over 30 minutes, about the same amount of time we ran it last night before we changed out any of the components. And it's still running without a hitch. I played some checkmate, and right now I got it in the automatic scribbling, where it's just drawing different designs here. And so far it's ran flawlessly. The 10-volt voltage regulator is still holding at 9.97 volts. It's been pretty steady. It's been there for quite a while. So the replacement of the 10-volt regulator is a success. I'm a little disappointed, though, because it's still putting that 9.97 volts out on the custom chips. And from what we gather from the schematics on the Golf Arcade game, is supposed to be, or they're wanting 8.5 volts. So yeah, it could be putting more voltage to these custom chips, and that could cause them to overheat and could cause them to not last as long. But let's go ahead and do another thermal check and see what they're running at right now. First, let's do the 10-volt regulator and see what that's running. With the old regulator, it was getting it up there around 135 before it started flaking out. So let's see what we're getting the temperature on the new regulator now. All right. And right now, the hottest it's got is 117.6. Okay. These other regulators, that's the 5-volt regulator. Let me restart this. I don't want to get a false reading here. The 5-volt regulator is only 89 degrees. This transistor is in a 5-volt regulation circuit. It's either tip 31 or tip 32. I can't never remember which, but it's got a pretty hefty heat sink on it. So I'm going to get this from the other side here, and then I'll get a reading of it. And that too is the hottest, is 118.7. So that's not bad all in all. Okay, let's do the custom data chip and see what the temperature of that is. And that's actually not bad from what I remember. Hottest it's getting is 112.8 degrees. Okay. Next, let's do the custom address chip, which is the one I'm taking the voltage reading off of. And let's see what we're getting on that one. Ooh, well, that one is the hottest so far, 126.6. Okay. Let's now do the I/O chip, which is this one right here. And that one is only getting up to 111.9. Okay. Let me just feel them by touch. The I/O chip just feels lukewarm. Now this one is hot to the touch, and as soon as I touch it, the heat kind of goes away, it dissipates. It's hot, but it's not so hot that I can't put my hand on it. All right, the one with the heat sink. Let's see what that one feels like. Ooh, that one's pretty hot. I can't leave my finger down on that one. All right, let me check the 10-volt regulator. Feels pretty warm, but it's not hot. No problem. I can hold on to that. This tip, 31, 32, whatever it is, warm, but I can hold on to it. 15-volt regulator, or maybe that's the, yeah. No, that might be the negative regulator. I'm not sure. Both of these are running pretty cool. All right. This resistor that's got the little resistor piggybacked on it, that's getting a little warm. Okay. Gee, I really don't know. I mean, obviously we fixed the 10-volt regulator. It's now steady. It's still running at 9.97 volts. But ideally, it would be nice if we could get that down. So I'm still wondering, could I replace that 10-volt regulator with another regulator that would drop that voltage down? And would the system work with that in there? I don't see why not. It's a fixed voltage regulator. That's something to look into. Let me know in the comments. What do you think? Do you think in order to put the lesser voltage on those custom chips, should I attempt to change that regulator and see if we can do it? And what regulator would I put in there? I'll have to look and see. Like I say, I'm not sure of the 7800 series. I think they make an 8-volt regulator. Maybe even a 9-volt regulator. 8-volt, well, would that be too much? Because even with the bad 10-volt regulator, it was still putting like 8. It only got down like 8.24, but it was still above 8 volts. So I would need something between, well, ideally 8.5 volts. But 9 volts would be okay. I guess it would be a little more than what I'm looking for, but it would still be less than 9.97. So, yeah. Let me think about that. Also, what do you think about the idea of the guy in the newsletter that put a resistor going to the chip to cut the voltage down? Instead of putting it on the chip, could I cut a trace on the board at the 10-volt regulator and put a resistor in between the output of the chip and the feed going to the board? Would that be a modification we could make? I'm just thinking out loud right now. I'm going to think about this. I think what I'm going to do right now, though, I'm going to go ahead and I'm going to call this a semi-success. It's not overheating. Things are still running a little warmer than I would like, but that came loose. Let me get that out of there. But it's running at a steady voltage now, so and it's not going to flake out because the voltage regulator is overheating. So yeah, we'll take it as a kind of a success. So what I'm going to do is I'm going to go ahead and put this back together. I'm going to end this video right here. Let me know in the comments what you think about the findings so far. And what do you think about maybe changing that 10-volt regulator to something a little bit less and giving it a try. But in the meantime, I'm going to go ahead and put it together, and something came in the mail today. Got a box here. And on the next video, we'll open this box. What is in the box, you ask? Well, it's games for the Astrocade. Now, it's not game cartridges per se. It's game ROMs, the ROMs that are in the cartridges. And I got one cartridge. I got what they call a bubber cartridge. So if you want to know what a bubber cartridge is, be sure to subscribe to my channel and look forward to the next video where we open this box and we get the bubber cartridge out and we see if it works with the game system, and we'll try a few different games because right now we're just limited to the 4 programs that comes built into the game system, which isn't really fantastic, but hey, you know, there are a few good games on this system. The graphics aren't high res, but for what it is back in the day, they were pretty good, and they still hold up pretty good today. So, yeah, let's go ahead and do that. So I'm going to end it right here, and this is just be another arcade fix. Well, at least we fixed something. We got the voltage regulator fixed. So, have you had your arcade fixed today? Bonus footage. Got it all back together. And we're playing some Checkmate. I boxed myself in. Still won. Okay, well, join me for the next video, and we'll put it through its paces and try out some new games. Not new games, but new to me, and find out if this thing is still going to have the overheating problem or if we solved it. So stay tuned.